Check out what we made in class today. Tornadoes. It was easy. Want to guess what's in there? Let's give it some time to separate. What do you think this mixture's made of?
Well, I can see that there are two different liquids, but even though we mix them, they still stay separate. So I'm thinking oil and water?
Yep. Oil is insoluble, which means it doesn't dissolve in water. Oil and water don't look any different when you mix them together.
You know, some mixtures are like that. Hey, what's that?
That's a mixture of some screws and nails from my garage.
Well, I could have told you that, Mr. Simpson, because when you mix screws and nails together, they're not going to change.
You're right. Let's start separating them so we can move on to the next mixture.
But that'll take all day.
What if we use this magnet?
How did you know to pick the magnet?
When I bought the nails a while back, I noticed that the box they were in said iron nails. Iron, nickel, and cobalt are magnetic, and I'm guessing the screws must be made of something else because they're not attracted to the magnet.
So the nails are magnetic, made of iron, and about 2 inches long. And when you mix them with the screws, nothing changed about the nails or the screws. I'd say this is a regular mixture.
I agree.
Okay, so what do you want to do next?
I want to try sand and water. Sand is tiny, gritty, brownish, and a solid, while water is clear and a liquid.
It doesn't look like anything is happening, Mr. Simpson. The sand is just moving around in the water.
Yeah, and when I stop stirring it, the sand just settles to the bottom.
This is also a regular mixture. It's like the ocean. The sand gets moved around the water, but it doesn't disappear in the water. Eventually, it settles to the bottom.
That's right. Both substances kept their properties. Now let's try mixing something else.
I have this water, and I have these sugar cubes. Let's put them together.
With this mixture, it looks like the sugar cubes are gone. They've disappeared. Olivia, would you like to taste it?
It tastes sweet.
Great. That means that while the sugar is no longer visible, we know that it's definitely still present because the water tastes sweet. This means that the sugar has the property of solubility. It can be dissolved.
So, if the stuff we mix together stays the same and keeps its own properties, then it's a regular mixture.
And if anything looks different about any ingredient that we mix, then it's a special mixture called a solution.
Now, how are we going to separate the solution?
While we think about it, why don't you make a list of tools that you might use to separate the sugar from the water?
How about the strainer?
We can try it, but I don't think it'll work, Olivia. Remember, since the sugar dissolved, it'll probably just slip right through the strainer with the water.
Maybe. If we put this filter in the strainer, it'll help block the sugar. No, the sugar's still in the water. The filter paper didn't catch any sugar.
Wait, I've got an idea. If we add heat to the water, it'll turn into a gas. The gas will evaporate, then the sugar should be left behind in the pan. Now that the pan has cooled down and all the water's evaporated, look at all that stuff in the bottom. Olivia, would you like to taste?
It's sweet. We got our sugar back.
I'm excited that we figured out ways to separate almost every mixture we made today.
Me too, and I think I have the perfect challenge for us to tackle next. While we give it a shot, you might want to try it too. Mix 10 grams of sand with 10 grams of salt. Using the tools available in your science lab, see if you can separate the sand and the salt based on their properties.
Oh, I can't wait. This is going to be cool. See you next time.